Good morning to one and all. Myself, Govardhan DS. I am from Tripoli. My topic is about CV configuration of transistor operation. Explain analog electronics. First of all, transistor configuration. Quote of the day: Try not to become a man of success, but rather try to become a man of value. Here we can see the block diagram of forward transistor configuration. Here we can see forward bias and reverse bias. This is the block diagram of the transistor configuration. Next, modes of operation. Here we can see the modes are cutoff, saturation, active, reverse active. Here EBJ, CBJ and applications. These are the after that BJT amplification, relationship between the collector current and the base current in a bipolar transistor. Characteristic is approximately linear. Magnitude of collector current is generally many times that of the base current. The device provides current gain. Here we can see the formula beta DC is equal to IC by IB, and beta AC is equal to delta IC by delta IB by IB. And this is the graph of the BJT amplification current. And next, BJT amplification voltage. The output voltage V0 can be calculated as V0 is equal to V minus ICR. When input voltage Vi change the VB changes, which cause IB to change. The change in bias in base current produces change in collector current. Delta IC is equal to beta DC delta IB. The change in collector voltage delta VC is equal to delta ICR. The voltage amplification AV is, these are the formulas of BJT amplification voltage. And next, here we can see the example of BJT amplification. Determine the DC collector voltage for the circuit shown below the if the transistor has the input characteristics shown inside figure and beta is equal to 80. Calculate the circuit voltage gain when input saturation is plus or minus 50 megawatts. Solution from side figure IB is equal to 15 for VB is equal to 0.7 voltage from figure 2. These are the figures of and V is equal to 18 volts, 18 volts, and R is equal to 10 kilo ohms, which beta is given. Beta is equal to 80 and delta VB is equal to plus or minus 50 megawatts. And it is the simplification of this example. And next, transistor configurations. In transistor configurations, it is converted into three types: common base configuration, common emitter configuration, common collector configuration. First of all, common base configuration. These are the block diagrams of common base configurations. And next, common base configuration means the common base configuration with PNP and NPN transistors are shown in the figures in the previous slide. The term common base is derived from the fact that the base is common to both the input and output sides of the configuration. The arrow in the symbol defines the direction of the emitter current through the device. The applied biasing are such as to establish current in the direction indicated for each branch. This is the direction of IA is the same as the polarity of VEE and IC to VCC. Also, the equation IA is equal to IC plus IB still holds. And next, input characteristics. The driving point or input parameters are shown in the figure. An input current IE is a function of an input voltage VB. For various output voltage VCB is equal to. This closely resembles the characteristics of a diode. In the DC mode, the levels of IC and IE at the operation point are related by alpha DC is equal to IC by IE. Normally alpha is 1. For practical devices, alpha is typically from 0.9 to 0.998. This is the graph of input characteristics for common base transistors. And next, input characteristics condition. And as an approximation, the change due to changes in VCB can be ignored. The characteristics can be shown in orange curve. If piecewise linear approach is applied, the magenta green curve is obtained. Furthermore, ignoring the slope of the curve and the resistance results the magenta curve. It is the magenta curve that is used in the DC analysis of transistors. Once a transistor is in on state, the BE voltage is assumed to be 0.7 volts and the emitter current may be at any level as controlled by the external network. And next, output characteristics of the graph. And next, output characteristics of the common base transistors. and output characteristics. The output set relates as an output current IC to an output voltage VCB for various of level of input current. There are the three regions of interest: active region, cutoff region, and saturation region. In active region, the BE junction is forward bias, whereas the CB junction is reversed bias. The active region is the region normally employed for linear amplification. Also in this region, IC is equals to IE. Cutoff region. The cutoff region is defined as the region where the collector current is flowing. In the cutoff region, the BE and CB junctions of a transistor are both reversed bias. Saturation region. It is defined as the region of the characteristics to the left of VCB is equals to 0 voltage. In saturation region, the BE and CB junctions of transistors are both forward biased. Thank you.